Okay, we're on to part two. Part two, I'm going to do a complete hyperbola problem where we go from the form of the equation that looks like this, a big long polynomial with x's and y's. We complete the square, we get it down to what's called standard form. Then I'm also going to graph it, and we'll see what that looks like, and hopefully it matches up with Desmos when we're done. So our first step on this problem is we are going to take this thing, we're going to collect the x's, we're going to collect the y's. We're going to move the constant over. So I'm going to take it 9x squared minus 36x. I'm going to leave some room here just for emphasis. I'm going to have to put something in that spot. Minus y squared minus 6y. And I'm actually going to group it with that negative sign and put a plus in between them. And then I'm going to minus the 18 over in my head, and I get minus 18. From there, I need to make sure the leading coefficient of the x squared is 1. So I'm going to take that 9, I'm going to factor it out. 9, I'm left with x squared minus 4x plus some unknown value. And I'm going to take the negative 1 out of both. Negative 1, y squared plus 6y plus some unknown value equals negative 18 plus two things that I don't know. Now, what we got to do is we have to complete the square on this. So the rule was you take the middle term, a 4 here and a 6 there. You take half of it and then you square it, and that's what goes in the blank. So half of negative 4 is negative 2. Negative 2 times negative 2 is positive 4. So I'm going to put a 4 there. But what I really just tacked onto that spot wasn't just the 4. What I really tacked on there was 9 times 4, which is 36. And to get the two equations to balance out, if I put 36 on one side, I got to put 36 on the other side. So I'm going to add 36 in that blank. All right, half of 6 is 3. 3 squared is 9. Plus 9, I'll put a 9 right there. And what I really just tacked on there was a negative 9. So I'm going to put a negative 9 right there. And those values you see in red, it's what we call completing the square. So I completed the square. Completing the square turns these into what's called perfect square trinomial, and what that basically means is it's factorable into x and x. X times x is x squared. Factors of positive 4 that get me negative 4 are negative 2 and negative 2. And if you notice, if you foiled in your head, x squared minus 2x is negative 4x. Negative 2 times negative 2 is positive 4. And that turns it into 9x minus 2 squareds. Likewise over here, negative 1, y, and factors of 9 that add to 6 are 3 and 3. Negative 1, y plus 3, quantity squared, equals, doing the math over here, negative 18 plus 36 minus 9 is positive 9. So I'll put a 9 there. Now, I'm almost there. I'm almost to the equation of a hyperbola. I notice there's a minus sign there. I notice there's a 9, so that's good things, but that's supposed to be 1. The prevailing characteristic here is that that 9 value over there is really a 1. So I'm going to take that 9 and I'm going to divide it over. Here they cancel. X minus 2 quantity squared over 9 divided by 9 is 1. I put it down there for emphasis. Minus, this is y plus 3 squared over 9 equals 1. And this is really the form of the equation that we're going for. We're trying to get that into that. And you're at home, you have Desmos out right now. What you can do is you can put that in on your Desmos, and you can put that in on your Desmos. And the hope would be that the two are the same. And if I've done everything right, we indeed have the pieces right. What I'm going to do now is I'm going to go over and I'm going to finish the problem by doing a complete graph. I know you have Desmos, I know you know what it looks like, but we have to be able to analyze this and be able to pick out all the pieces also. So first of all, HK is my center. Remember to change the signs. So my center is at positive 2, negative 3, positive 2, negative 1, 2, 3. That's the center of basically where the asymptotes are going to cross. The center of the reference rectangle that I'm going to draw, the quote-unquote center of the hyperbola is kind of what it is. This is a hyperbola that opens left and right, and I can tell it opens left and right because the x1 is the positive value and the y1 is the negative value, and I see a 1 under that. The one that's positive is your a value, so a squared is 1, which means my a value is 1. My b value is the part underneath my negative sign, so b squared is 9. You notice in the equation that this spot is the a squared spot and this spot is the b squared spot. So my b value is 3, and what that really tells me is how big the reference rectangle is. So I'm going to go 1 on the x-axis, I'm going to go 3 on the y-axis. So 1 on the x-axis, and I'm going to go 3 on the y-axis. Like that. And those little dots over there, what that allows me to do is it allows me to draw in the reference rectangle. Something like that. Okay? A and B, we got that. I'm going to go ahead and find C right now because I'm over here. The equation for hyperbola was c squared equals a squared plus b squared. My a squared value is 1, my b squared value was 9. 1 plus 9, that's radical 10. That's my c, my c squared was that. So my c value is root 10. And really that's like, I don't know, 3.1-ish. I'm probably not perfect there, but it's close to 3.1. And what that does is it puts your foci inside of the hyperbola 3.1 units from the center. And what that means is that from here, I'm going to go 3.1, 1, 2, 3.1, 1, 2, 3.1, just a little bit over there. And then this way, 1, 2, 3.1, puts it about right there. But really what that distance is that distance is radical 10. That distance is radical 10. So if I was going to list out the foci, I would say my foci are at, well, I'm over 2, down 3. I'm over 2, down 3. But then on the x direction, I went root 10 to the right and I went root 10 to the left. So onto this one, I'm going to add root 10 to the right and root 10 to the left. And the way that will get written is 2 plus or minus root 10, comma, negative 3. And that's where your foci should be. Okay? It's kind of weird. Now if you put 2 plus 3.1 and put like 5.1, and you put 2 minus 3.1 and put like negative 1.1, that'd be fine. It's just a different way of writing it. That's probably the most exact way of writing it. But if you use a decimal, I'd be fine with that. Okay? So we got the foci. Let's draw on the asymptotes. So I'm going to change colors here. I go red asymptotes. Now the asymptotes, what they do is they connect the corners of the reference rectangle. It goes through the center, goes like that. That corner of that reference rectangle through the center, about like that. And the foci contain, we said this is a left-right open and parabola, so this is a really, really drawn out branches like that. And these branches, it goes through this A bow, that end point there, that vertice, it goes through there, goes like that. And we really have a really good picture of it right now. We just have to list out a couple more things. So let's do that. The foci we have, the vertices are these spots where the hyperbola comes down and goes through. So right there is a vertice and right there. So it's over 1, down 3, over 1 to the right, and then down 3. And the other one would be over 1, 2, 3, and down 3. So over 3 and down 3. So I have the vertices. I have the foci, I have the A, B, and C value. I guess the only other thing would be the equation of the asymptotes. And just because of where it's sitting, I could use y equals mx plus b. I'm going to go to more of a calculus concept. I'm going to use that point slope formula, and I'm not even going to change it to y equals mx plus b form. But the point slope formula is y minus y1, m, x minus x1. And I don't know, I'll do, I guess I'll just do it on the graph. I'm going to write the equation of this one right here. So y minus, and x1 and y1 are some random point on that asymptote. And the reason this is great is because they go through the center. So I can use that center value, which was at, oh, I don't even think I listed the center. So I'm going to list the center. The center of that was over 1, 2, down 3, over 2, down 3. I can choose that for my x1 and my y1. So I can go y minus my y1 value, which is -3, equals my slope. Well, I went up 1, 2, 3, and over 1. 3 over 1, x minus my x1 value is 2, just cleaning it up a little bit, y plus 3 equals 3, x minus 2. My other one, this asymptote right here, I'm going to use the same point, y minus a -3, but now my slope is down 1, 2, 3, and over 1. So equals -3 over 1, x minus 2, and I'll go y plus 3 equals -3, x minus 2. And I could really change those into y equals mx plus b if I wanted to, but next year in calculus, you're just going to be leaving it in point slope form anyway. So now, what you can do, you should already have these two on Desmos. You can take that and put it on Desmos, and that and put it on Desmos, and the hope is that we have everything right. I actually haven't even plugged this in on Desmos yet, so I'm going to go do that myself. Hopefully I got it right, otherwise I'll have a makeup video on what I did wrong on the next one, but this should allow you to now do the homework that's posted, the worksheet that's posted online. Good luck.